This is Jacob's Algebra, chapter 14, lesson 3. This is more on irrational numbers. So if you know that y is equal to x to the n, then we would say that y is the nth power of x. You can also say that x is an nth root of y. Now, notice I didn't say x is the nth root of y. That's because sometimes there's more than one root. For instance, if you have 81 and then positive 3 to the fourth is equal to 81 and negative 3 to the fourth is equal to 81. So both positive 3 and negative 3 are fourth roots of 81. So when you see the symbol that looks like this, the nth root of x, that generally means the largest nth root of x. So when you see the fourth root of 81, that usually means just the positive 3, not the negative 3. So you need to go by context and see whether you are supposed to give the answer as 3 and negative 3 or just as 3. In this textbook, just saying the fourth root of 81, that generally means just the positive 3. So in order for the nth root of a number to be rational, the number that you're taking the nth root of must be the nth power of an integer. So if we are taking the nth root of y, that will work just fine so long as you can write y as some integer to the nth power. If y is some integer to the nth power, then the nth root of y will be a rational number. If y is not equal to an integer to the nth power, then it will be an irrational number. Okay, so let's start working on some problems for this one. Okay, I'm going to pause this and draw up a grid. Okay, so problem number 4, which is the first problem in set 2, says copy and complete the following table of powers. So the first column is x, and they're going to want you to do this for x equals 1, 2, 3, 4, and 5. And then they want you to find x squared, x cubed, x to the fourth, and x to the fifth for each one of these values of x. We're only going to do a couple of these on the video because you can do the rest at home. So 2 squared is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. 3 times 3 is 9, times 3 is 27, times 3 is 81, and then times 3 again is 243. Now we're going to jump down to the 5. 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 again is 3,125. So this is number 4. It is just like number 11 that I assigned as homework. So all you need to do is make this grid and start filling in your powers. Okay, let's move on and do number 5. Number 5 says use your table, that's the table that you made in the previous problem, to tell whether each of the following numbers is rational or irrational. Express each of the rational numbers in simplest form. So, like for part A, we have square root of 8. So let's go back to our table. And do we see an 8 in the square column? We don't. We can see that 2 squared is 4 and 3 squared is 9. That means there isn't an integer that we can square to get 8. So that means that the square root of 8 is irrational, and I'm just going to write a capital I instead of writing out irrational. Okay, part B, the cube root of 8. So now we go back to our table on the previous page. Look in the cube column and see if we see an 8. 8 is the cube of 2. So the cube root of 8 is going to be 2. So if our answer is rational, we need to find what that rational answer is and then identify it as rational. Part C, square root of 25. Okay, we go back to our chart on the previous page. Do we see a 25 in the square column? We do. 25 is the square of 5. And that means that the square root of 25 must be 5, and that is rational. Okay, part D. We have the cube root of 25. Okay, so now we're going to look for 25 in the cube column. Well, we see that the cube of 2 is 8, and the cube of 3 is 27. 25 falls between those two numbers, so it cannot be the cube of an integer because there's no integer between 2 and 3. So that means it is irrational. Okay, part E, square root of 81. We go back to our page. We look in our square column for 81. Oh, actually, we don't have one big enough for that. I'm sorry, our chart doesn't go that high, but the square root of 81 is actually 9. So some of these your chart may not help you with. Our chart just doesn't go up that high. And that is a rational number. For part F, we have the fourth root of 81. So now we go back and we look in our fourth column, our x to the fourth column, and there we see 81 is the fourth power of 3. So that means that the fourth root of 81 must be 3, and that is a rational number. And actually, it's 3 or positive 3, but we can just write the positive one because in this textbook, when it just gives you this form, they want the biggest one. Okay, part G is the cube root of 1/27. Now that is the same as the cube root of 1 divided by the cube root of 27. Now you know the cube root of 1 is going to be 1. Let's see if there's a cube root of 27. So we go to our cube column. 27 is the cube of 3. So we can say that this is 1/3, and that is rational. Okay, so now I'm going to clear this page, and we'll continue with some more of these parts. Let's look at, yes, number 5, part H. Hold on, I'm not in pen mode yet. Number 5, part H, which says the square root of 8/81. Well, we can, actually, no, we can't simplify this. So we can look for 8 and 81 in our square root column. I'll tell you 81 does have a square root, that's 9, but 8 does not have a rational square root. This is the same as square root of 8 over square root of 81. And so we would have square root of 8 over 9. But square root of 8 is irrational, so that means that we are irrational. Even if part of it is rational, if any part of it is irrational, then the answer is irrational. The next one we have is the fifth root of 1/100th. That's the same as the fifth root of 1 divided by the fifth root of 100. Well, the fifth root of 1 is just 1. Let's see what the fifth root of 100 is. Okay, 100 falls between 32 and 243. There is no integer between 2 and 3. That means the fifth root of 100 must be an irrational number. So I'm going to write fifth root of 100. So that one is irrational. And then for part J, we have the fourth root of 16/625. That is the same as the fourth root of 16 divided by the fourth root of 625. So if we go back to our table, in our fourth power column, 16 is the fourth power of 2, and 625 is the fourth power of 5. So that means what we have here is 2/5, and that is rational. So for number 5, which is just like number 12 that I assigned as homework, for each problem you have to determine whether the answer is going to be rational or irrational. If it is rational, you have to find that rational answer. You can't just write rational. You have to find what that rational answer is. If it is irrational, we could stop all the way back here and just say irrational. You don't have to do anything more if it's irrational. You just might need to do something to be able to figure out that it's irrational. So stop the video. You should stop the video now and work problem number 12 in the homework. Again, make sure that you identify everything as either irrational or rational. I'm fine with just using a capital I for irrational and a capital R for rational. Just make sure I can read it. Okay, so let's move on now to number 6. Number 6 says a table listing some of the roots of 5 and 0.5 is shown below. Each root is rounded to the nearest thousandth. And I'm going to pause the tape and pop up the table. Okay, so this is the chart that's printed in the book for problem number 6 in set 2. So the left column shows you the value of n, and then the middle column gives you the nth root of 5. So we've got the square root, cube root, fourth root, fifth root, and then the last column gives you the nth root of 0.5. So square root, cube root, fourth root, and so on. Okay, so question A wants to know, what happens to the nth root of 5 as n gets larger? So what's happening? We have 2.2, 1.7, 1.5, 1.4, 1.2, 1.0. What's happening to the value of the nth root of 5? Well, it looks like it's getting smaller. So I'm going to say gets smaller. Okay, question B. It says, what number does the nth root of 5 get very close to when n is very large? Well, notice the 10th root is about 1.2, the 100th root is about 1.01, and then the 1000th root is 1.002. I'm going to say that it's approaching 1 because it looks like it's going to get very, very close. Going from the 100th root to the 1000th root, we only moved from 1.016 to 1.002. So I'm going to say it's going to approach 1, but probably not actually get there. Okay, part C. What happens to the nth root of 0.5 as n gets larger? Well, let's see. We've got about 0.7, 0.79, 0.84, 0.87, 0.93. That's getting bigger. So I'm going to say gets bigger. Okay, part D. What number does the nth root of 0.5 get very close to when n is very large? Well, notice the 100th root of 0.5 is 0.993. The 1000th root is 0.999. I'm going to say it's getting very close to 1, and looks like it probably won't ever actually reach there. So that's number 6. It is just like number 13 that I assigned for homework. So you should stop the video now and work number 13 and then come back to the video. Okay, so now we're going to look at problem number 7. Problem number 7 refers to a graph that's shown in the book, and I'm not going to try and recreate that here. And it says the graph of the function y equals x squared can be used to estimate square roots of numbers. For example, from the graph shown here, we can see that the square roots of 6 are approximately negative 2.4 and 2.4. So when you look at the drawing in the book, you can see where the value of 6 is, and a green line has been drawn that's horizontal from the value of 6 to the left and to the right. Actually, I will pause this and draw it. Okay, so I've gone ahead and kind of tried to freehand some graph type lines here. You do need to use graph paper when you're doing this. I just don't have graph paper available for my virtual whiteboard. It would be nice if that was a feature though. Okay, so what they graphed was y equals x squared. So we know that when x is 0, 0 squared is 0. 1 squared is 1. I want you to notice that my x-axis is on a scale of 1 for each notch, but my y-axis is on a scale of 2 for each notch. So 1 and 1 is going to be here, negative 1 and 1 is going to be here. Okay, then we need to square the 2. 2 squared is 4, so I'm going to put that up here. And then negative 2 squared is also 4. 3 squared is 9, so that's going to go about here. And negative 3 squared is also 9, so that's going to go about here. 4 squared is 16. And negative 4 squared, ooh, try and do a straight line. I think that's about right, is about 16. Okay, and then 5 squared is 25. And negative 5 squared is 25. Back